Okay. If you can hear me, snap once. If you can hear me, snap twice. 10 years. 10 years. Ernesto, what do you have for 10 years? 1,859. Is that correct? Yeah. 20 years. Brody, what do you have for 20?
21, 21549.
21549. 50 years. Did it, depending on how you rounded? Okay. 50 years. Jerry?
32,684.
Do we agree?
Yes.
Okay, so we're getting the hang of that, plugging it in. Now, here is where we may want to use intersect. When we have time, we can plug in x's for value, but when they give us a population, those are y's. Okay, and the intersect function is going to work better there. They have given us a formula already to use, and this is a different town. Let's hear what's happening at this town. Christian, could you read, please? Morristown.
Morristown population rates and population is decreasing at a rate of 1.2 function. PT equals 18,000 times 0.9885. Other population and function. Using the graphic calculator is the number of years will take from population to each day.
Okay, so the first thing, go ahead and go into y equals. We need to change this to the new function. 18000. You see this one is a decreasing function, so it's getting times by something smaller than 1. Sam? All right. When we're going to use intersect, we're putting this in for the second y. So I go down to y2, and I go 1, 5, 1, 2, 3. I'm going to get rid of that 0 just so that it doesn't mess us up. So we're going to find the intersect between that amount of population and our particular town. Second calc. Go down to intersect or push 5. Let it think a minute. First curve. Are you guys with me? Mine says first curve. I want to change my window so I can see it. Zoom 0. It didn't. Window. Oh, there it goes. I guess it's window. X-min, I'm going to put negative 100. And, oh no, the X's, I'm going to put negative 30, positive 30, scale of 1. And Y-min, I'm going to put, what did we start with? Oh, I'm going to put 0, and it's only going to go up to 18000. Okay. Second calc. Intersect. I was just trying to see my graph because, that doesn't, well, let's see what happens here. There we go. Now, once you have it where it says first curve, you push enter. Second curve, you push enter. And then it says guess, you push enter. And you can see that the cursor is right there where those two intersect. This is the constant amount of population. That's not our town. It's not staying at a steady amount. This is the decrease. That's our town. That intersection's happening with y of 15,000. What we're looking for is what's the x. That tells us after 15.1 years, the population has gone down to 15,000. How about half? What did it start as? 18. And then what's half of 18? 9,000. So I go back to y equals, and what do I need to change?
Y2.
Go down to y2, change that to 9,000. Second calc, intersect. And I really like being able to see. I'm going to change my window. Let's say X max 100 and going by twos, enter. Second calc, intersect. So I could see mine was going off the screen this way, so I needed an X that was a bigger X max. First curve, enter. Second curve, enter. Guess, enter. Intersection. 9,000 happens after how many years? 57.4 years. Now, while you... What?
How is this working?
Yeah,
So at 17,000, it's 4.7 years. At 15,000, it's 15.1 years. 15,000 is less than 17,000.
It's decreasing. The population is going down, not up.
Yeah, I was thinking that too.
I was like, what?
Okay, so it's decreasing by a kind of a small amount. What's 1/3 of 18,000? 6,000. Okay, so you guys go ahead and do 16, 17, and 18, and I'll walk around. Okay, go to white equals. Oh, so maybe you don't need top. It looked like you were doing second calc. Intersect. First curve, enter. Second curve, enter. Yes. And see how it was, how the graph was up here? Window. So what we need are, here X max is 3. I've changed that to like 100. And maybe change the other two. That means it wasn't showing you past 3, and then it has trouble thinking too far past 3. Scale 500. Let's see what happens.
So we didn't.
Now, try this again. Yes.
Throw your dog a bone.
Hold on a minute. Jenny, what was that? 2. I can't hear you. 2 point. Thank you. You don't have to do it. That's why, Jenny. You're ready to move on to Unit 2. I mean Unit 3. Okay. Let's see. I hear a couple people having issues with this, but I think some people are ready to move forward. So we'll come back. What do we get for population right here? 91 years. How about 0? Were you able to find a 0? Error because it's an asymptote. Okay? It gets close to 0 but can't. So never. That's what the asymptote means. Our graph is coming down towards 0 but never touching it. How about 10,000? Excuse me? 48.7. All right. Taking a look at these graphs, let's see what they want us to do. Complete each table, graph the function, identify the x-intercept, y-intercept, asymptote, domain and range, and interval of increase or decrease. Let's see. Tables we can figure out how to do. X-intercept, I bet you over and over they're going to say none. Y-intercept is where does it crisscross the y. Asymptote is y equals 0. Domain, all real numbers, range, y greater than 0. Intervals of increase, increasing. Yeah, let's not worry about that domain and range stuff. If we can get this table, this graph, and a y-intercept, I'll be happy with us. Okay, so flip the page. Okay, a couple different ways we can go about this. First of all, they give us a function, they give us x's. We could put it into our calculator and make a table. We could also just plug it on in. I think I'm going old school for this one. Mode clear. Clear. Here's my function, 4 to the x. Here's my x. So I'm going to go 4, raise it to a -2. I'm just keying it on in. Enter. I'm going to go 4, raise it to a -1. Enter. I already know. What's 4 raised to a 0? Try again. Yep, 1. Any number raised to a 0 is 1. 4. What's 4 raised to the 1? Okay, is 4. And what's 4 raised to a 2?
16.
Thank you. So some of these I had to put into the calculator. Others look like this. Now, if I'm going to graph these points, I'm going to go with whole numbers first. 0, 1. Now, this is marked off for the y's in 4s. So that's 2. So 1 is halfway. 1, 4. 1 is 4. It's half a box. 2, 16. 2 is 1 box, and 16 is up here. They gave us kind of a tiny graph. All right. I wonder if this one goes below the graph. No, because here we go. -1 is 0.25. What kind of tiny little pen do they think we have? -2 is 0.0625. I'm going to make that bigger. this is what we got for dots. I'm going to continue a curve on up, and continue a line on back. Y-intercept. Where does that one hit the y-axis? Y-intercept, when x is 0, y is 1. So right here, this is the y-intercept. That little spot is y-intercept. How about x-intercept?
Never.
That's the never. Okay. Now, again, there's different ways to do this. That time, I just did 4, put in a new fraction, a new exponent. 4, put in a new exponent. We can create a table. Let's go to y equals, clear out our old stuff, clear, put in parentheses, 1 divided by 3, parentheses. Fractions, I think the best way is put them inside parentheses. And now we're going to put x as an exponent. Second, table set. It's right above window. I'm going to start it at -2, -2. And I'm going to go up by 1 each time. That's what this table's doing. -2, -1, 0, 1, 2. So table set was in the window, but I had to push second. Now I'm going to push second table, which is over here above graph, second table, and there's my values. When, up am I going? I'll make it a little smaller. When, I gotta go this way, to write with the right hand. When x is -2, y is 9. When x is -1, y is 3. When x is 0, y is 1. And I've got 0.33 and 0.11. Okay, so I used the x's they gave me and the function to create a table. Now to graph this, at -2, we're all the way up at 9. At -1, we're up at 3. That's in between the 4 and the 2. At 0 on the x-axis is right here. We're at 1. At 1, we're at 1/3. And at 2, we're not at 0. That's what this is, a decreasing function, but it's skimming down to that x-axis. Up, over. Y-intercept happens where it crosses the y-axis, also known where x is 0. We crossed at 1. X-intercept, do we have one? Looks like none. All right, you do number 22. You do number 22. I never turn these guys back on. Oh no, there they are. Good.